Now, here's a solid of revolution. Rotate it to cross-section view. Rotate it back. Our problem is to find the volume of this solid. Now I'm going to open it up and pull it around till only half the cross-section remains. This is the area that we rotate to get this solid of revolution. Now let's open it out again. Its cross-section the other way is circular. We'll solve our problem with disks. Here's a nice one. And it's circular, too. If its radius is r and its thickness is h, then its volume is pi r squared times h. Let's use this one. Fit it on the solid. The edge of the disk intersects the top edge of the cross-section in a point. I'll call that point an anchor point. Now let's call the solid's axis the x-axis and sketch a y-axis in the plane of the cross-section. Suppose the equation of that top curve is y equal f of x as x goes from A to B. Now let's fill the solid up with disks. It isn't exactly the volume of the solid. Let's figure out how much volume it is. It'll be easier to see in cross-section view. Those anchor points project down to points on the x-axis. I'll call them T1 up to T6. Remember that top curve is y equal f of x. So the first anchor point is T1 f of T1. The second anchor point is T2 f of T2. And the last one will be T6 f of T6. Also, the faces of the disks intersect the x-axis in points. I'll call those x0 up to x6. And now we know 2 dimensions of each one of those disks. The thickness of the fourth one, that's x4 minus x3. Say delta x4. And its radius is going to be f of T4. That means that its volume is going to be pi times f of T4 squared times delta x4. We have 6 disks here, so the total volume of those disks is the sum from 1 to 6 of pi f of Ti squared times delta xi. Now let's slip in another disk, and the sum goes from 1 to 7. And another goes from 1 to 8. Another, 1 to 9. As this process goes on indefinitely, the total volume of those disks approaches the limit as n goes to infinity and the delta x's go to 0 of the sum from 1 to n of pi f of Ti squared times delta xi. But this limit is just the definite integral from a to b of pi f of x squared dx. And since we know how to calculate a definite integral, we're done.